Okay, hello class. In this video, I'll be discussing an example in the application of Newton's laws where the applied force is variable. Okay, so unlike in the previous example that I have, the forces acting on the system, yung three-body system nga na example ko no last time, the forces there, the tension, the frictional force, all were time independent, meaning while these forces are acting on the objects, the strength and the direction do not change with time. So, tumatakbo ang time, pero yung magnitude and direction ng force, hindi siya nagbabago, constant siya. Kaya as a result, when we get the net force acting on the particle, since the net force is constant, then the acceleration, the resulting acceleration is also time independent, meaning it's also constant. So pag ganon, since constant net force results to constant acceleration, then the constant acceleration equations that we have can always be useful. Either the acceleration happens in the x-axis or the acceleration happens in the y. But in this example, in PowerPoint 4.2 for the application of Newton's laws, ito yung problem number 4, no? So I am expecting na you are somehow trying to solve those problems on your own. And I think you can do it on your own, yung 1, 2, and 3. So I decided to make a video on how to solve problem number 4. Okay? So in this problem, you need to apply the things that you learned in your integral calculus, no? So anyway naman ang gagamitin natin sa physics na integration is the simple ones lang, kasi yung masyadong matataas na parang nasa theoretical na yon. So itong sa atin, yung simple power rule lang will do. At saka kung trigonometric like this na sine function siya, we can always check the table of integrals, no? You don't need to memorize anything. Kaya helpful na mag-print kayo, mag-download kayo ng values of different common integrals at saka table of derivatives, no? Para pag meron kang na-encounter na problem like this, you can always look at your codigo kung anong klaseng integral siya. Okay, so much for that. So I'll just read the problem. It says that a certain force, and then the force is given, F sub x equals C sine quantity pi t over capital T. Okay? So this is an indication that the force really is along the x-axis kasi may subscription na x. So nag-a-act siya sa x-axis. Where, sabi, itong si C at saka si T are constants. So, the author has to tell us that C and T are constants because we need that when we do the integration. No? So this fx as a function of time, no? Sinusoidal siya, meaning periodic. So, meaning paulit-ulit. I hope you can still recall in your trigonometry na pag sine function, ano siya, periodic. Para siyang tawag nito, repetitive yung pattern niya. Merong time na 0 siya, tapos mag-increase, tapos bababa, tapos pupunta sa negative, tapos mag-decrease ka agad. And then parang ano siya, sine wave pag i-graph natin. So, this force, which is sinusoidal, is being applied to an object of mass m, and the object mass m moves on a horizontal frictionless surface. So, remind mo kaagad si self mo. Frictionless surface. The object is moving on top of the surface. So, si coefficient of kinetic friction dito, 0 kaagad. And then, horizontal siya. Therefore, yung x-axis natin, horizontal. Okay. Next. The object is at rest at the origin at time t equals 0. So, this is very rich in information. Object is at rest at the origin. So, meaning, the velocity along the x-axis, when time is 0, is 0. That's the initial velocity. We can also write this as v sub naught x. as the initial velocity. And then it is found at the origin when time is 0. So the x position when time is 0 is also 0. Okay? So ano yan siya? Importanteng information yan. So for the first requirement, we are to find an expression for the object's velocity. And then you graph your result for this time interval from 0 to capital T. So, finding an expression for object's velocity, this is another way of saying na ibigay mo ang velocity as a function of time. So, we already have several examples for that, no? So, si letter A, kailangan nating mag-establish ng equation ng velocity at any time. So, this is velocity as a function of time. Pag meron na tayong expression nito, maglalagay tayo ng time values here between 0 to t para makaplot tayo ng graph within this time interval. So, how do we do this now? Since we know that, ito sabi dito horizontal, frictionless. So, as the object, so let's just say, if the object were this, ito si Masha, let's say si force x at a certain time, di natin alam, at certain time t, ito si fx, okay? So, itong si fx ngayon will result na gagalaw ito at that particular time. Now, frictionless man, so walang friction dito sa ilalim, 'di ba? Therefore, pag-apply ni fx kay m, walang kumukontra sa kanya, then we can say that this force along the x is ito na mismo yung summation ng forces sa x. I hope you agree. Kasi wala mang friction, wala namang tension. So, the total force is just equal to the sinusoidal force here, Fx. Second, this, sabi kanina, the velocity of the particle when time is 0 is also 0. And then, nung in-applyan na siya ng force, magkakaroon siya ngayon ng velocity. So, meaning, yung object mo nag-speed up. 'Di ba? Speeding up ito. Speeding up in a straight line. So, kung speeding up in a straight line, we can say na present si A parallel in the same direction with the V. And then, si A perpendicular, 0. Kasi, hindi man nagkurbada ang direction. Diba? This changes the direction of the motion and this changes the speed. So, whatever is the A parallel, yun na rin mismo yung acceleration vector A natin. So, I hope you make it a habit, no, na hindi kayo parang mag-segregate nga ng principles kasi you can always use na halos maraming principles pag nag-analyze ka na ng system. So, dito, sinali ko na yung na-discuss natin before na A parallel, A perpendicular para lang mas ma-reinforce pa natin ang understanding natin. So, meaning to say, di ba sabi natin, if there's a change in speed, even if it goes in straight direction, the system is still accelerating. Okay. So, obvious na ni Kaayo nga naman, kay sinabi niya, wala naglihok pag start sa timer, and then later mo lihok siya. So, meaning, accelerating siya. Okay? So, pag sure ka na yung system mo is not in equilibrium because it's accelerating, edi the law of acceleration ang gagamitin mo. Meaning, itong total force na ito, it's equivalent to the mass of the moving object and its acceleration. Tama ba? So, doon tayo mag-start. Okay? Start tayo doon. Second law. Application of second law along the x. By the way, pag move ng box dito, wala man siya nag-bounce, no? Wala siya nag-accelerate sa y. So, it's in equilibrium along the y-axis. The acceleration here is along the x. Ito, a sub x. So, we say that, second law, mag-start tayo second law. It's already 9 minutes. The summation of the forces along the x is equal to mass times acceleration along the x. Okay? Ang goal natin is v as a function of time. So, let's further simplify. Itong si summation of fx, sabi natin, ito na yung sinusoidal force fx. So, lalagay ko siya, si fx, yung given. And then, si a, I will write A in terms of velocity para lumabas si velocity. Okay? So, I hope you agree that acceleration is just equivalent to the time derivative of velocity. Tama? At as a function of time. Okay. Now, ito yung gusto natin na i-solve, 'di ba? Si velocity. So we can tawag nito simplify, no? So si fx di-divide ko dito ito si m kasi ang gusto kong matira sa right hand si dvx. Okay? So pwede ring hindi muna natin to isulat, no, kay samok siya. Okay, basta kay velocity as a function of time 'yan. And then I'd say this is dt so that in my right hand side I'll have dvx, an infinitesimal value of velocity. Gamay kayo na siya nga interval. Okay? Now, if i-flip ko siya ha, dito ko ilagay sa left hand side, i-rewrite ko lang. So, the infinitesimally small value of vx, okay? And then rewrite ko muna, fxm dt. Okay. Si fx, ilalagay ko na ang value ni fx. C sin pi t over t. So, I'll have c na may m sa baba. Pwedeng i-rearrange ko na kaagad as c over m. And then, I'll have sin, tapos pi t over t dt. This is now our expression for dvx. Now, I hope you learned in your integral calculus na itong si dvx sa calculus natin, si dvx is just a small, a very infinitesimally narrow interval, strip, 'di ba? So kung gusto natin kunin si vx talaga, 'di ba, i-integrate natin, i-add na natin lahat. Okay? Something like that. So singit sa ano lang sa tagamay ha, kanang intermission. So later na lang yan. Anyway, sige, dito na tayo. So, ang gusto ko ngayong makuha is si Vx, not si dVx. So, what I will do is, I will get the integral of dVx and my limits would be from 0 to a certain value Vx. Okay. So, kung nag-integrate ako sa left, natural mag-integrate din ako sa right. Dito sa right, si C at saka si M, 'di ba constant ito? So, I will put it at lalabas ko siya sa labas ng integral ko. And then, I'll have the integral of, itong buo. Sin pi t over t dt. And then this will be, so the integrating variable is time. So from 0 time to final time t. Okay? And then I can just rearrange this in such a way na it will be in a form that's more familiar para mas madali tayong pumili ng integral sa table mamaya. Okay? So, simplify muna natin ito. So, ito, di ba merong Vx dito raised to 0, tama? So, this will just be Vx, and then the limit natin is from 0 to Vx. So, I hope you know this already in your calculus, ha? Okay. And then, ito i-rewrite ko muna in a more familiar pattern. So, I'd say that this is sine, and then I'll have pi over t dt. Okay? Yan. I've mentioned earlier na hindi kailangang i-memorize ang integrals, 'di ba? Pero kanang dapat paspas kayong makakita ng pattern. So ito, kung titingnan natin sa form, dito ako ha. Set it aside for a while. So if we say that the integral, you can see this in any table of integrals. We have sine, itong form, ax dx. And then the integral of this is negative, and then i-reciprocal natin to si a. Tapos cosine, and then ax ulit. Okay? So dito, sa problem natin, si pi over t, si A. Tapos si t, siya yung x dito. And then you have here your dx. Tama ba? So following this, our answer here for the integral of the left side, okay, is just, so meron ka pa ring c over m dito. And then this becomes, ang integral is negative, reciprocal ni A. So, ang reciprocal nito is t over pi. And then, I have negative here. Negative t over pi. And then, I'll go cosine. And then, ax. So, ifa-follow ko lang ito ulit. Pi over t times t. Ayan, okay? And this is integrated sa limit from 0 to t. Okay? Itong si left, so, di ba, isa-substitute natin si upper limit here minus the lower limit. So, this becomes vx minus 0. So, this will just be vx. And this will be vx as a function of time na ito. And then ito, isa-substitute natin din si t sa lahat ng small letter t, of course. Tama ba? So that this becomes, and then this minus 0. So, wala na akong space. Diri ko sa taas, ha? I hope you can still understand this. Klaro ba? Okay, sige. So, paki-check kung wala ko isipyat sa substitution, ha? So, ito siya. And then, i-replace natin si upper limit kay t minus itong buo ulit, and then isa-substitute si lower limit kay t. Okay, so help me. So dito sa left hand side, it's vx of t na yan, 'di ba? Solve na natin 'yan. Meron ka pang isang tawag nito. Itong si t at saka si pi, pwede na nating ilabas sa labas kay constant man na siya, no? Tama ba? Yeah. So, this becomes negative c t over m pi. Yan. And then, ang natira sa ilalim, you have cosine pi over t times t. Tama? Wait. Yeah, tama. And then, minus, itong buo ulit, tapos na naman kay negative, so plus na ni siya. Plus, ct m pi, kita pa ba? Okay. Cosine pi over t, and then instead of writing t, I'll write 0. So, this is upper limit minus negative of lower limit. Okay? So, further simplifying, this becomes negative ct m pi cos pi over t, and then itong ito 0 times pi over t becomes 0, and then cosine of 0 is positive 1, tama? So ang natira dito sa kabila will only be so plus ct m pi. Yan na lang natira sa kabila. Okay? And then, I can factor out ct over m pi. And then, ito, unahin nating sulat muna ha ang positive muna unahin ko ha. Ct m pi. And then, minus itong first term. Ct m pi cosine pi over t times t. So, ako lang siyang gibalhin og sulat ha. Dito sa kabila, this is still vx of t. And then, I can factor out ct. So, ct over m pi. So, itong term will be 1. Tama? Tama ba ang sign natin? This is positive. Wait. Yeah, tama. So, this becomes 1 and then minus, tapos ito, cosine pi t over t. Okay? Mag-ana na lang ko. Na. So, this is now velocity as a function of time. This is now our final answer. Okay? So, ayaw ka-intimidate sa mga symbols ha, kaya ato man na siyang tanawon. Okay? So, ayan. So, the resulting velocity as a function of time this time is a cosine function. Tama ba? So, mag-plug in tayo ng values ngayon ni t from the time interval 0 to capital T para ma-plot natin siya. Okay? Sige. Wait. Tanggalin ko muna itong isa. So, ang gagawin natin next ngayon, kailangan natin ng values ng v at different times para maka-plot tayo ng v as a function of time. So, how do we do this? Start muna tayo sa original equation. So, this is now the expression for the object's velocity. Hindi makita. So, Vx of t, we have these constants. So, at this point, wala pang binibigay na values, no? These are all constants. Mass times pi, and then I'll have 1 minus cosine pi, excuse me, over t times t. Okay. So, obviously, the velocity as a function of time is also changing periodically. No? So, na-time nga 0, nya musaka, na-time nga baba, kay cosine function man ni siya. So, what are the important times here? Siyempre, katong gihatag sa ato na time interval, 0, and then you have t. So, si t nato na between 0 to this constant t. So, I'd say we'll have let's say time, and then this is velocity along the x. So, let's say time is 0, and then probably we'll go half of this, t over 2, and then we'll have, let's say, sa pamandong gisolve na ko nakuan ha, time values. Pwedeng diretso na lang tag t, diretso. T, and then 1 and 1/2 dayon. 3 halves t. Okay, solve natin para magkaroon tayo ng points. Okay, dito tayo. So, when time is 0, I'll have c t m pi 1 minus cosine pi over t, and then I have here 0. Okay. So, cosine of 0, sinabi na natin kanina. Let me use the orange pen. So, this becomes cosine 0. So, cosine 0 is positive 1. Tama ba? So that we have 1 minus 1. This is 0. So, ayan. Na-prove natin yung sinabi kanina. That the object is at rest at t equals 0. Okay? So, anyway, pwede na pala nating ilagay na lang diretso sa table, no? Kasi nakalimutan ko na sinabi pala ito. Pero, it's a good thing na na-validate natin through the equation that it's 0. Next, let's go velocity when time is half of t. So, itong mga nilagay natin dito, yan lang naman ang isa-substitute natin sa t. Kasi this is variable na no? With this v depends on t. Okay. So, I'll have c t m pi, and then I'll have 1 cos pi over t, and then I'll have t over 2. Okay. So that this becomes, ayan. So, ano nga ang cosine ni pi over 2? Diba? Cosine of pi over 2 is 0. Tama? Okay. So, this becomes, our answer here will just be, so ito magsi-0. Excuse me. This is ct m pi. Ayan. So, this is ct over m pi. And then we have vx When time is t, balik-balik lang guys. Ako lang yung gipakita, no? Para for the benefit of everyone. At saka pag merong hindi naintindihan, the good thing is you can always replay this video. So, that's something that we cannot do in a face-to-face class. Kaya di man pwedeng masikog balik-balik sa kong lecture, no? So, itong si online, at least, naakay abilidad na magbalik-balik hantod sa masabtan nimo. So, I think that's a very good thing. Okay. It's like a silver lining behind the dark clouds. Okay. Oh, yan. So, this is equal to 1. So, what's cosine of pi? Yes, it's negative 1. So that this becomes 1 plus 1 equals 2. And then you still have CT m pi 4. So, meron kang multiplier dito na 2, no? Nag-increase siya by a factor of 2. 2 and then CT m pi. And then finally, velocity when time is 3/2 of t. So, 1.5. CT. So, I guess you know now what's the answer here, no? Yan. Cosine pi over t times 3t over 2. Cancel. Cosine, oh, yan. So, bumalik ulit siya sa bumalik na siya sa anong answer natin dito? 0. Yan. So, this becomes CT m pi. Pag nagdagdag ka pa ng pag 2t na, okay, so lagay muna natin CT m pi. Pag sinubstitute mo si twice t, babalik ka ulit sa 0. Yan, okay? So, we are now ready to graph this one. Velocity, Hiwi. Sige. So, this is time. Okay. Walay specific unit, no? Kay variable lang siya. And this is velocity along the x. So, if you look at your intervals here, we can have the interval by CT m pi. Pi yan. Okay. So, I'd say if this is CT over m pi, then another unit would be twice CT over m pi. And so on. And then, ang time interval ko is ito, ang follow ko. So, I'd say this is 0. This is pi over 2. I'll have 3/2. Pi over 2. T over 2. And then, this one is 3/2 t. And this is twice the t. So, the graph now we'll have 0, 0. And then, dito siya. Yan. And then, when time is t, dito ka sa 2 pi. 2 ct, And then, 3/2, balik ka ulit sa ct. Masyadong sharp ang curve ko. But anyway. Ayan. So, more or less, our best fit line, yan. And then, mag-continue na yan kasi periodic siya. Okay? So, anong ibig sabihin ng graph na ito? It's just saying that the resulting velocity, itong object na ito, yung pag-push kasi sa kanya, mukusog, muhinay. So, natural lang na ang velocity niya, ganun din ang pattern. Bibilis, maximum, tapos babagal, magsisiro ulit. So, ito siya ngayon yung maximum. Kasi ito yung peak ng natin, diba? Bx max natin. Okay? And then, finally, tapusin ko na lang talaga ha. Ay, nahurot na. 29.